Welcome. In Chapter 3, we will be looking at some mathematical formulas. You'll finally get to use that calculator for the course, and we will be exploring different statistics that help us compare data. And in this section, we will be looking at different measures of center of data, and we'll learn how to calculate the mean, the median, and the mode for a list of numbers. So let's begin. Some characteristics of data that we use when we look at our values is we have descriptive statistics, which in descriptive statistics we want to summarize the characteristics. So like in Chapter 2 where we did all of the graphs, a graph is a way to give a visual summary of the data. And in this chapter, we're just summarizing the numbers by looking at the mean and the median and the mode of the data. Inferential statistics is where we explore ways to make generalizations about the whole population, and we'll be getting to that in future chapters. When we look at a measure of center, the one that we're most familiar with is the mean. The mean is found by adding up all of the values in the data set, and then we divide that by the number of values that we have. And so we see this formula here that has a Greek letter in it, and this letter that looks like an E is the Greek letter sigma. And every time we see sigma in a math course, it always means find the sum. And then right after it you see x. So this means find the sum of all of your x's, and x's are the individual values. And then below that, we're dividing that by n, and every time we see n used, that is the value or the number of values total that we have. So n is always total. The mean may or may not be an actual number in the set. It's an average. And in statistics, the way that we denote the mean is we say x bar. So x with a little bar above it is the mean of the sample. And then the mean of a population, we pronounce this Greek letter as mu, so it looks like a letter U, and so that's the mean of the whole population. Page 85 in your textbook also has the different notation definitions for you. This is the calculator that is recommended for you to use in the class. It's a Texas Instruments TI-30X, and this calculator is extremely user-friendly, and it has very simple buttons to use to do our statistical calculations. So whenever I give calculator tips in the course, it's always going to apply to this calculator. It does not apply to the Casio or to the graphing calculator, the Texas Instruments, the 84s, the 85s, and so on. Now, we can always calculate the mean the long way by adding up all of the values and dividing by the total number we see. But we don't want to do that because our calculator can do it for us. And another reason why we want to use the calculator to find the mean is we also will be using some other options in the calculator to do something called standard deviation. And so it's best to just put all the data in and let the calculator do the mean, since we'll do other things with it as well. The first step to find the mean is press the blue second button, which is the top left corner, and then after that press the data key. The data key is above the number 8. Press second data and then use your arrow button, which is at the top right hand side of your calculator, and keep pressing the right arrow until it says clear data. Once you underlined clear data, press enter. Now press second data again and arrow over to 1 var stats, and then press enter. This sets your calculator up in stat mode. At this point, you're ready to type in the numbers. So press data and enter the first number. This first number will be entered after the symbol that says X1. Press the down arrow key twice. The reason why I say press it twice is after X1 and you press down, it'll say F1, which stands for frequency. So if you have a number that appears multiple times in your data, like maybe you have the number 5 that repeats 20 times, And if you don't want to type that number in separately 20 times, you can just enter the frequency of 20 for that number. But most of the situations that we'll encounter, we don't need to do that. So just press down arrow until you get to X2, press the second number, press down twice until you get to X3, and so on. Once you've finished entering in all of the data points, now you're ready to calculate. Next to the data button is a button that says Stat var. This is above the number 9, and it's next to the button that says Clear. The Stat var button is the Calculate button for our class. Once you press Stat var, you will see a bunch of different titles listed, and use your right arrow key and keep pressing the right arrow key until you get to the symbol for mean, X bar. Once you get to that symbol, you'll see a value above it, and that is the mean for the data. We will now do an example to practice calculating the mean. So get your calculators ready, and on the next slide you'll see the example. The measurements shown below were recorded at Building 5 of the World Trade Center site on different days immediately following the destruction caused by the terrorist attacks of September 11th. Use the calculator to find the mean for the sample of measured levels of lead in the air. So we have these data values listed. Let's go ahead and calculate the mean on the calculator. First, press Second Data, right arrow to underline Clear Data, then press the Enter, which is the equals button. Now press Second Data once more, arrow over to 1var stats, and press Enter, or the equals button. Now you are in stat mode, and you will see on your home screen of the calculator the word Stat. Now just press Data. It says X1. Enter the value 5.40 and then press the down arrow key twice. You can enter the frequency of that number, which the default is 1, or just down arrow until you get to X2. At X2, type 1.10. Press down twice. At X3, press 0.42. Then go down to X4, press 0.73. Go down to X5, type 0.48. And then go down to X6 and type 1.10. When you finish entering the data, immediately press Stat var, which is the button next to Clear. Use your right arrow key to find X bar symbol. And the X bar symbol is the mean. The median is another measure of center. The median is the exact middle of the data. And to calculate the mean, we have to first arrange the data in order from least to great. The median may sometimes be a value in the set, and if there are an even number of pieces of data, like if we have 12 numbers, then the median becomes the average of the two middle values, since there isn't a number exactly in the middle. If you have an odd number of pieces of data, like 11 numbers, then you have to find the exact middle number of the data. The notation for median is X with a little approximation symbol above it. We're going to take these same measurements and we're going to find the median for these measurements now. So if you remember, the first thing that we have to do is write the numbers in order from least to great. So I've sorted the values here in red. Now how many numbers do we have? Let's count them. We have 1, 2, 3, 4, 5, and 6. So when we have an even number of data points, we need to find the line that separates the data in the middle. So I've drawn a line in the middle. So I have 3 numbers to the left, 3 numbers to the right. To find the exact middle, I have to add 0.73 and 1.10, and I divide that number by 2. So we're finding the average of the two middle numbers. If you're typing this in your calculator, you do need to put the parentheses around the 0.73 plus 1.10 before you hit divide by 2. So the median is 0.915. What we're going to do now is repeat the preceding example, but we're going to throw in an extra measurement. So I've sorted the values in order from least to great, and I've included the extra measurement of 0.66. Now, if we count the numbers, we have 7 value points. So since there's an odd number, there is a number exactly in the middle, so let's circle that number. When I circle 0.73, I have 3 numbers to the left and 3 numbers to the right, so this is exactly in the middle, and there's no further calculations. The median is 0.73. A third measure of center is the mode. A mode is a value in our data that repeats most often. So the mode is a value in the set. Let's find the modes of the following data sets. So we're looking for a number that repeats the most often here, and the number that repeats most often is 1.10. It repeats twice, so that is the mode. If we look at the second example, we see that we have the number 27 that repeats 3 times, the number 55 repeats 3 times, and the number 88 repeats only twice. So since we have a tie for the most times of repeating, this is a bimodal data set. It has 2 modes, 27 and 55. This third example has no repeating numbers at all, and so we say no mode. It would be incorrect to say 0, because if you put the number 0, you're implying that 0 is an actual number in your data set. So when there is no repetition, make sure you say no mode. And finally, another way to find a center is to find the mid-range. And this is another little formula that you'll need to know for this test. The mid-range is the value where we take the highest number, add it to the lowest number, and then divide that by 2. The mid-range is the value midway between the maximum and the minimum values. And since the mid-range only uses the maximum and minimum values, it's not often used in statistics. Here we're going to put it all together, and we're going to find the mean, the median, the mode, and the mid-range for the data that corresponds to this word problem. A dietitian obtains the amounts of sugar from 100 centigrams in each of 10 different cereals, including Cheerios, Corn Flakes, Fruit Loops, and 7 others. Those values are listed below. Is the mean of those values likely to be a good estimate of the mean amount of sugar in each gram of cereal consumed by the population of all Americans who eat cereal? Why or why not? So here we're just given some numbers that correspond to the data obtained in this problem. And since we're going to have to find the median, let's go ahead and rearrange the numbers in order from least to great. So I've done that here in red, and that's what you'll need to do when you first start these problems. Okay, so the mean, we would use our calculator to do that. So get your calculator, press the data button. Make sure your data is cleared from previous problems before you do this. So to clear your data, you press second, data, arrow to clear data, press enter. Now press the regular data button and type in all of your numbers. Once you've typed in the last number, press stat bar. Stat bar gives you the calculations that you'll need. Arrow to the right until you have underlined X bar, which is the mean of the sample. So we should get from the calculator the mean is 29.7. To find the median, we're going to find the middle of the numbers. And so since they're written in order and we have an even set of numbers here, the median is going to fall between 30 and 39. So to find the value when it's between two numbers, we add them up and divide by 2. So 30 plus 39 is 69, and 69 divided by 2 is 34.5. The mode is 47 because that's the number that repeats most often. It repeats twice. And the mid-range, we take the low number 3 and the high number 47. We add that up and divide by 2. So 3 plus 47 is 77. And divide that by 2, and you get exactly 25. And then to answer the extended question, the sample values are not necessarily typical of cereals that are consumed by the population of all Americans. Many students question how to round the answers that they get in the calculator, and so we have some suggestions for doing that. The round-off rule from the mean, median, and mid-range. Always carry one more decimal place than is present in the original set of values. So for example, if you're asked to find the mean of 2, 3, and 5, which have no decimals in it, and then you get this value in your calculator, 3.33333 repeating, then we would round this to one decimal place, 3.3. The mean of 80.4 and 80.6 is 80.50, and the reason we have 80.50 is because we want to go one more decimal place than the original values, and the original values have one decimal place. How do we calculate the mean when we have a frequency distribution? So recall that a frequency distribution is a table that has classes on the left, and then it tallies up how many are in that class on the right column. And in Chapter 1 and 2, we talked about frequency distributions. In Chapter 2, you learned how to set them up and how to interpret them and find the midpoints and such. So in a frequency distribution, we don't know the exact values. Remember, it's tallies. So we're not able to find the mean by just adding all the numbers and dividing by how many there are. That's impossible. So we have to get an approximate mean, doing it a little differently. So what we do is we assume that all the values are equal to the class midpoint for each class. So in order to calculate the mean, we first have to find the midpoints of each class. And remember, the way we find a midpoint is we add up the two numbers and we divide it by 2. So if we had an interval that goes from 0 to 9,999, let's say that that was the first class, and the frequency was 46 next to that, then what we do is we find the midpoint of the class. So we add 0 plus 9,999, we divide that by 2, and we get 4,999.5. So then we assume that all 46 values are equal to 4,999.5. The frequency distribution only gives us an approximation of the mean. It's not an exact mean since we can't see the original list of values. We have a formula to help us calculate the mean from a frequency distribution, and this is found on page 90 in your textbook. So it's x bar equals the sum of f times x divided by the sum of f. So let's talk about what's going on in the numerator of this fraction. The Greek letter sigma means sum, and after that you see what you're supposed to do first. It says do f times x. Well, f is your frequency of each class, and x is the midpoints of each class. So we're supposed to first multiply the frequencies by each midpoint, then we add those products. Next, it says find the sum of the frequencies down below, and then we're going to divide the top and the bottom to get the approximation for the mean of the frequency distribution. What we're going to do here is practice finding the mean for this frequency distribution, and we're using daily precipitation in inches, and the frequencies are listed next to that. You can see that what I have done first is I've set up a brand new table where I started with my frequencies and I found my class midpoints, 0.245, 0.745, 1.245, and so on. And then I have a third column which is f times x. So I did 31 times 0.245 and I got 7.595. And I continued that pattern. Another thing for the formula that you'll need to do is you need to add up your total frequencies. So I add the frequency column and I get 35. Then we have to total up the column that's the f times x. So I get 14.575. The mean is equal to the sum of f times x divided by the sum of x. So I take 14.575 and I divide that by 35 and I get 0.41643. So the average precipitation level is 0.42 inches of rain. Now up above here you'll see a video tutorial that you can click on which has more steps demonstrated for you, and that's a good tutorial to watch. So why do we have different measures of center? Well, it's because they do different things. The mean is a really good approximation if there are no extreme values or outliers in the data. So if all of our numbers are increasing at a normal distribution, then the mean is what we want to use when we are talking about the average. However, if we do have outliers, like let's say that most of our numbers go from 2 to 10, and then we have a value like 100. Well, that value of 100 is going to really affect the mean because it adds up all the numbers and divides by how many there are. So it's going to give us an inflated value for the mean. So in that situation, the median is a better measure of center because it knocks off the outliers and it goes to the exact middle of the data. And then mode and mid-range are discussed, but they're really not used when we actually do our statistical calculations that often. And then I just wanted to talk about skewness. On page 92 in your textbook, you'll see that it discusses what skewness is. That is a distribution that extends more to one side than the other. So it's not a bell-shaped curve. And in this situation, when we have skewness, the mean is always further in the tail because it's most affected by those extreme high or low values. So in picture A, that's normal bell-shaped distribution. The mean looks like it's right in the middle. The distribution is centered around the mean. However, this picture in part B is called skewed right because the mean is stretched to the right by those outliers that are pulling the graph out. And then in picture C, that's a picture of values that are skewed left, where the mean is stretching to the left.